Okay, we are on chapter 9, section 2, and we're going to talk about certain classifications of acids and bases. And we're going to talk about strong acids and bases. So remember when we said acids and bases are things that dissociate? Well, there are really actually two different ways that it can dissociate. It can dissociate completely, where every single molecule that started with this and that turn into the ion of this and the ion of that. And so that's 100% dissociation in water. Not all acids and bases do that. Some like to hang out together and don't like to dissociate very much. They do a little bit, but not very much. So we're going to first start with the ones that dissociate 100%. So they form hydronium ions and they form anions if we're talking about acids. So here's an example of an acid, HCl, hydrochloric acid. And so in combination with water, it is going to form our hydronium ion and then the chlorine ion. And so there are certain sets of strong acids and bases, and I will provide this table to you on an exam, but there's a few shortcuts that you can take in order to not have to go and reference a table all the time. So our strong acids, if they're only two elements like HCl, right, that's hydrogen and chlorine, that's binary, meaning two. Just remember, I bring clay. So HI is a strong acid. HBr, so I, Br, and Cl, I bring clay. Those are the three strong binary acids. So those are here, HI, HBr, HCl. Then there are strong acids that contain oxygen. And the way that you know that they are strong or not is you count the number of hydrogens and oxygens. And what you are looking for is two more oxygens than hydrogens. So in this case, let's look at perchloric acid. We have one hydrogen and we have 4 oxygens. That gives us 3 more oxygens than hydrogens, so it's strong. In sulfuric acid, we have 2 hydrogens and we have 4 oxygens. That gives us 2 more, check, right? Come down to the bottom, we have in nitric acid 1 hydrogen, and we have 3 oxygens. So that gives us 2 more oxygens than hydrogens, right? And that's how we know that these are strong. So those are 2 little shortcuts that you can use to remember. I will give you a table, but all right, so acids are either strong or they're weak. And so weak acids only partially dissociate. And so anything that is a weak acid, there are a couple of, oh, I didn't want to do that. There are a couple of things that you can know. Weak acids are carbon containing, containing acids. Not all weak acids are carbon containing, but if it has carbon in it, it's weak. So one example is acetic acid, right, which is the main component of vinegar. So in this case, we have our acetic acid. So this one is acetic, if I could write, acetic acid, right? And that acetic acid, if you put it inside of water, is going to turn into an ion, right? So we have lost our hydrogen. We go from having a hydrogen to having no hydrogen and having a negative charge. And where did that hydrogen go? Well, the water picked it up and became positive. So what this is saying is this is a weak acid. So this acetic acid likes to stay as acetic acid. And you only, if this is 100%, right, then only 5% of it will turn into the ion in solution in water. The rest of it, the other, because we had 100%, the rest of the 95% is going to stay as acetic acid, okay? So if we look at what this would look like in a picture, right? Hydrochloric acid is strong, acetic acid is weak. So if we look at hydrochloric acid, right, HCl, what's going to happen is you're no longer going to have any hydrogen bound to chlorine. All of the hydrogen is going to go hang out with the water and make hydronium, and all of the chlorine are going to be chlorine ions, right? So if you put it in water, what are you going to get? You're going to get H3O plus Cl minus. Okay, so it all forms ions, 100%. You have 0 of this left, and it all turns into the product. Okay, a weak acid is the opposite. A weak acid, you're starting with acetic acid, CH3COOH, and you put it into water, and what happens? Well, that CH3COO will lose the hydrogen and will make H3O plus. But it doesn't happen completely. So what you can see is, here's the ion, here's one molecule that's an ion, and that's the only one I see, right? Here's one hydronium ion. All the rest have stayed all together as acetic acid and are uncharged. So 95% is still the original, and only maybe 5% is the product. So that's the difference between a strong and a weak acid. So you can also do the same comparison with bases. Strong bases, for example, NaOH, sodium hydroxide, sometimes it was olden days called lye, are used in household products, right? What's that spray that you use in your oven? Don't ever get it on your hands. Always, always, always wear gloves. It's a very strong base, and it will eat through your skin. So be very careful with that. Same thing with drain cleaners. You know, the stuff that comes in the bottle and you pour down the drain to loosen a clog, something like that. Do not touch it. Do not get it in your eyes. Be very, very careful because it's a very, very strong base. So our Arrhenius bases that we were listing before, those group 1 and group 2 metal bases, those are strong. They dissociate completely in water, right? And they give you that metal ion like LiOH goes to, like in water, Li plus OH minus, right? So they dissociate completely. But bases that are weak only partially dissociate. So one very common weak base is called ammonia, is NH3. And so, so I'm in a room with a motion sensor. So I was too still for too long. It's so funny. All right, so where was I? All right, so we've classified strong acids, strong and weak acids, strong bases, weak acids. Now we need to know how to name them. So when you name an acid, right, you have to look at what it was originally. So if you look at the original anion name, and if it ends in IDE, so like HBr, right? Okay, so this, what is this ion here? This is bromine, that's the atom, but what is my ion, Br minus, what do we call that? We call that bromide, right? So bromide, if I look at the IDE, then I come to my table and I say, okay, bromide, I'm gonna put hydro, so HBr, is equal to hydro, and then my anion name, except don't put the IDE, hydro, BROMIC, bromic, because we don't add the IDE, and we replace it with an IC, and we say acid. So HBr is hydrobromic acid. If it ends in ATE, then that's something that you're going to find on the polyatomic ion table. And if it ends in ATE, then we're going to change the acid name to something that ends in IC. If it was polyatomic ion and it ended in ITE, we replace that ITE with OUS. So only the ones that are off of the periodic table that are binary, you do this IDE and do the hydro, bromic. That's the only ones you do that. These two that are ATE and ITE, these are polyatomic portions of the acid. And so that's how you name them. So I'm gonna give you a quick fun one. So if you're gonna go to the polyatomic ion table, right? So this is for the polyatomic ones, right? I went to chemistry class and I got 8-ic-itis. 8-ic-itis, ITOUS. I went to chemistry class and I got adic-itis, right? Sounds like you got this terrible disease, but really what it's telling you is if your polyatomic ends in ATE, change it to IC. If your polyatomic ends in IT, change it to OUS. It's kind of a fun one to remember. Okay, so what happens if you take a strong acid and add it to a strong base? Well, they're actually going to both completely dissociate. And so you would have those ions in water. And so you'll have the metal cations and the non-metal anions. Then you'll have hydronium ions and hydroxide ions, right? Hydronium is H3O plus, hydroxide is OH minus, right? So the hydronium and the hydroxide ions are actually going to combine and they're going to form water. So you'll get like 2 molecules of H2O. Whoa. And it actually comes with a lot of heat. So if you ever do this, be very careful because it makes a lot of heat. And so the metal cations and the anions will remain in solution as ions. And if you were to evaporate the water, all you would have left would be an ionic compound. And that would be like HCl plus NaOH. What's going to happen, right? Well, I know my HCl dissociates into H plus Cl minus, right? I know my NaOH goes to Na plus OH minus. Well, what happens? Look at this. I'm going to form water. So from this, I'm going to form water. And then what else am I going to form? Whoa, look at this. I'm going to form NaCl. What is NaCl? It's a salt. So any time you have a strong acid and a strong base put together, you're going to produce water and a salt. And that's called a neutralization reaction because the acid and the base neutralize each other when they react and they form water. And water has a neutral pH. Okay, so anytime that you're doing a neutralization reaction, if you see the word neutralization, then you need to make a product that is a salt and another product that's water. And you have to make your salt have a charge of 0 because like we had Na, what was it, Na? No. What did I do? Yeah, I did Na and Cl. So I had Na ions and Cl ions, right? And so you have to do your crossover, 1 and 1. So that's Na1, Cl1, but we just don't write it, right? So that salt product is a neutral ionic compound. So here's my example of a neutral ionic compound. And you can actually balance the equation by putting coefficients. So if you needed to, you can put coefficients out in front, but you cannot change the subscripts, right? Once you make that ionic compound, you can't change the subscripts. So just make sure it's balanced. So a lot of times there are cases where you have really a lot of really strong acid or strong base and you need to neutralize it. And one example of that is inside your stomach. You make stomach acid, which is hydrochloric acid, really strong stuff. And sometimes it gives people indigestion, right? And it gives them heartburn. And so people take over-the-counter antacids or sometimes prescription strength antacids. And usually they are a mixture of aluminum hydroxide. So hydroxide, so that's a base, right? We have a base and we have an acid. And then magnesium hydroxide, here's another base. And so aluminum hydroxide and magnesium hydroxide are not strong. They are weak. They're both weak bases. Hydrochloric acid, on the other hand, is a strong acid. And so the weak bases, the ammonium hydroxide and the magnesium hydroxide, are not very soluble. And so because they don't make a whole lot of OH minus in solution, it doesn't hurt your body to take them. That's why you can chew them, right? You can eat them. And so alone, they're not so good because ammonium hydroxide will actually produce constipation. And it'll bind to phosphate inside of your intestinal tract, which is not so good. You don't feel so good. You feel weak. You don't feel hungry. And then magnesium hydroxide kind of has the opposite effect on the body, and it'll actually have a laxative effect. And so what we do is we mix the two. And so you have very, very minimal side effects when you mix the two. But what happens in this is that you're still neutralizing some of the stomach acid. You're not going to neutralize it all, but you're going to neutralize a portion of it. Okay, so the other way that you can neutralize an acid is with carbonates. So when you have a carbonate, right, carbon containing, that's what we mean when we say carbonate, contains carbon. The reaction, so here's our carbonate right here, and we're going to mix it with an acid. And what's going to happen is we're going to make a salt. This is our salt. We're going to make water, and we're going to make carbon dioxide. Okay, and this actually occurs in your bloodstream. So when we have calcium carbonate, right, about 10% of the calcium is going to be absorbed into our bloodstream, where it's going to elevate our levels of serum calcium. And so you have to be kind of careful about this because you don't want to have too high of a concentration of some of these ions, because they can lead to things like kidney stones and even ulcers and things like that. But you can take sodium bicarbonate, right? And you can consume it, and you can affect the acidity level of your blood. And so you have to be very careful if you have damage to your stomach already in what you take. So you have to be very careful if you have peptic ulcers and things like that. So these are a few of the different but over-the-counter drugs that are bases that act to neutralize some of the stomach acid and things like that that we encounter on kind of a daily basis. Okay, so we're going to go do some problems. Okay. Here we go, 9.2, strong acids and bases. Which of the following are strong acids? So I gave you the table here, but you don't need the table, right? You don't need the table. So remember your binary, let me do it a little bit darker of a color. Our binary, which means two elements, I bring clay. So HI, HBr, HCl. Right? And then our oxygen is 2 more oxygen than hydrogen. That's all you have to remember. Okay, so which of the following are strong acid? Here I have 2 hydrogen, I have 4 oxygen. And so I have 2 more, right? So this one is strong. Which of the following are strong? So I'm just going to circle my strongs. HCl, look at that, it's in my list, HCl. HF. HF is binary, hydrogen and fluorine. Not on my list, so it is not strong. So this would be weak. Okay. All right, which of the following are strong bases? So remember your, oh, I think I mixed that. I mixed that up. But that's okay. Okay. So which of the following are strong bases? So our strong bases are our group, whoa, hello. Here we go, strong bases. It's like when my wrist touches it, it goes crazy. Strong bases. These are our group 1 and most of group 2 metals, right? So look at the different ones. I have potassium and I have lithium. Well, I know potassium is in group 1, lithium is in group 1. So these 2 are going to be strong. My last one that I have to worry about is NH3. NH3 was one of those you had to remember. This is one that you have to remember is a weak base. Okay. All right, let's see. Which of the following compounds, let's see, completely ionizes in water? What does that mean, completely ionizes? It is strong. Whether that's a strong acid or a strong base depends on what's inside of it, right? So HNO3. So if you look at here, now I'm oxygen containing, and I don't have a hydrogen, right? This is an OH, this is gonna be a base. I know this is a hydrogen, this is gonna be an acid. But over here, I have a hydrogen, and then I have a polyatomic with oxygen in it. So this is going to be an acid. And so now I need to know which of the ones are strong or which ones can completely ionize. And so if we look at HNO3, what we see is we have 1 hydrogen and we have 3 oxygens. And so that tells me I have 2 more oxygens than hydrogen. And so this one's going to be strong. NH4OH. If it's got NH4 in it, it's going to be weak. So this is a weak base. HF, we actually just did HF. So we said it was weak because it is not an I bring clay, iodine, chlorine, and bromine. All right, let's see, here we go. Name and write the formula for the acids formed from the following anions. So I'm going to give you this table. There's the table. I'm going to give you the table, but you don't really need it. If you remember, I went to chemistry class and I got 8-ic-itis, right? And then the only one you really have to remember is if you find it off the periodic table, right? So if I have Br minus, what I'm going to make is HBr, right? Hydrogen ions, a +1, bromines, a -1, so you get one of each, just like making an ionic compound. So I got bromine off of the periodic table. So if it ends in IDE, right, bromide, then I'm going to name it hydrobromic acid. Okay. Chlorate, ATE goes to IC. So this will be, it's a charge of 1, so you only need 1 hydrogen. If that were a charge of 2, you would need 2 hydrogens. And so it would end up being like H2, but we don't need that. So it would be HClO3, because you basically swap charges, you do the crossover, right? If you say H plus, crossover, it's 1 and 1. So ATE goes to, I gotta erase all this. ATE goes to IC, so this is chlor. Instead of ATE, I'm gonna write IC, and then I write acid, chloric acid. So NO2 minus, same thing, we have a hydrogen ion, and we're gonna swap them, so we get 1 and 1. So HNO2, and what we're going to make, we end in ITE, now we're going to make an OUS. So this is NiTr, and I'm not going to write the ITE, I'm going to write the OUS, nitrous acid. Okay. Complete and balance the following neutralization reactions. Okay, red flag. What's a neutralization reaction? I'm going to have a strong acid plus a strong base, and I'm going to make a salt plus water. Okay, that's what you need to remember. I'm going to make a salt plus water. Okay, so if I have HNO3 aqueous plus LiOH solid, what am I going to make? I'm going to make a salt. Where does my salt come from? My salt is going to be a metal and a non-metal, or a metal and a poly, or a polyatomic and a polyatomic. So here's my metal, lithium, right? So now I need to know what's my anion going to be? My anion is going to be a polyatomic ion, NO3. So when you write it, you just have to make sure that you get those charges right. So if you have lithium, go look on the periodic table. What's the charge on lithium? +1. What's the charge if you go in a polyatomic ion table of NO3? This is a -1. So lithium is a +1. So then you cross them over and you get 1 and 1. So this would be LiNO3. Now you're doing this in water, so you call it aqueous. Plus, you're going to put the other stuff together. What's the other stuff? Well, the other stuff is a hydrogen over here, and then an OH here. Well, what is HOH? HOH is water, H2O. And we always say that water is liquid, right? So are we balanced? Yes, absolutely we are. So we are good to go. Now, H2SO4 aqueous plus CaOH2. Now, remember how I said you have to be careful of the charge? So the charge over here and the charge over here, an hydrogen ion is a +1. SO4 is a 2-. So when you cross them over, the 2 is going to come down here. The 1 is going to go down there, okay? So that's why we end up with the 2. So when we do this, right, you always want to end up with salt and a water. So this case, let's do the water first. I'm going to make water. So here's my hydrogen, but look at this. I have 2 of them. Be very careful, right? And I have 2 OHs, right? So if I have 2 H's and 2 OHs, what am I going to make? 2 H2O, right? I'm kind of like pre-balancing things in my mind. Plus, what else do I have left? I have an SO4, right? And I have a calcium. So calcium is my metal. So calcium is going to be a +2. SO4 is going to be a 2-. Oh, so I can cross them over, but then I got to remember to reduce. So I go from having a Ca 2 SO4 2, then I can just remove it. And I can just say, I don't need the 2's, right? So I'm just CaSO4. And then we need to say what state of matter, and that's aqueous. That's supposed to be AQ. No, it doesn't look like it, but it's supposed to be AQ. Okay. All right. Complete and balance the following neutralization reactions. How many more of these we got? Let's see. Oh, last one. Okay. So we have HBrAQ plus AlOH3, and that's a solid. And it is going to, all right. Oh, do y'all notice what I did? Oh, that's a 3. Okay, make sure you copy your reactions correctly. Okay, so we have a hydrogen here, and we have an OH here. Now, I'm betting that this is not going to balance quite right, so I'm going to have to be careful when I do this. I know I'm going to make water. What else am I going to make? Well, I have a metal. Here's aluminum. And I have a non-metal. That's bromine. Okay, so be careful. What's the charge on aluminum? My aluminum is a +3. Gotta go look on the periodic table. My bromine is a -1. So if I combine aluminum and bromine, that is going to be AlBr3 aqueous. Am I balanced? Careful here. I am not. I am not balanced. How could I balance this equation? I'm going to need to put a 3 in front of my water. Kind of looks Christmassy. All right. What if I have HI aqueous plus CaCO3 solid? Okay, what's going to happen? Well, it's a neutralization, so I'm going to make some water. How am I going to make some water? Well, if I have a hydrogen here, that's going to be part of it. What do I need in hydrogen? I need hydrogen and oxygen. But how many oxygens for every water? I only really need hydrogen and 1 oxygen. I really need 2 hydrogens, and I need 1 oxygen to make H2O. Okay, that's gonna be my liquid. Y'all are just like laughing at me. There it goes. Okay. So I make water, and what else do I make? I make my salt. So where's my salt? I have a metal here, calcium, and then I have an anion there. So Cai, calcium is a +2, iodine is a -1. So that would be Cai2, and that is aqueous, but wait a minute. I have a carbon and I have 2 oxygens left, right? So that's what I have here. I have a carbon and I have 2 oxygens. What can I make with that? Carbon dioxide gas. Kind of cool, right? Okay, I hope you have a great rest of your day. Talk to you soon. Oh, I think I did that wrong. Y'all. Stop. Okay, there we go. All right, bye y'all.